So exercise 10.07 is a nice short and fairly easy exercise about solving exponential equations. So in question 1 we need to solve each of the following. So the first one is 3 to the power of x equals 9. Now that's really easy. We actually know the answer to that because we know that 3 squared equals 9. So we can just write 3 squared. But when you get a situation like 3 to the x equals 10, we know it's bigger than 2. So we could just guess and check. Now if I go 3 cubed, I'm going to get 27, which is way too big, because it's got to be pretty close to 2. So I could go 3 to the power of 2.1, for example, and I've gone too big. The answer is going to be smaller than 2.1. What if I change that to 2.05? Oops. Okay, now I'm less than 10, so that's too small. So it's somewhere between 2.05 and 2.1. What about 2.08? Still too small. Let's go a little bit higher. 2.09, still too small. What about 2.095? So you can see we're getting really close now. What about 7? Oh, too big, so somewhere between 0.95 and 0.97. Let's try 6. Too big, so somewhere between 0.95 and 0.96. Let's try 5.5. Too small. So you can see we could keep going like this for a long time. If we were asked to do it to say 3 decimal places, we do know that it's bigger than half here. So to 3 decimal places it'd be 2. It's going to round up at that third one. So this is going to round up to there. So 2.096 would be an okay answer to 3 decimal places. But let's actually solve it properly. So I'm going to show you 2 methods of solving it. The first method is probably my preferred method, and that's to take the log of each side using a base that is in our calculator. So you could use base e or base 10. It makes no difference whatsoever which one you choose. I'm going to do base e just because I use base e a whole lot more than I use base 10. So log base e of each side. And then with this we can use that rule where the x goes flying down the front. So x times log 3 log 10, and then all I need to do is divide each side by log 3. So divide by log 3, divide by log 3. So x equals log 10 divided by log 3. Now if I had done that with log base 10, it'd be log base 10 over log base 3. Either way you'll get the same answer. So if I go log 10 divided by log 3 using the natural log button, the answer is 2.0959 to 4 decimal places. So 2.0959 will do. If I'd used the LOG button, it just would have been log 10 divided by log 3, and you can see I do get the same answer, the 2.0959. Okay, let's look at the other method. So the other method is, because our base is 3, to take log base 3 of each side. So log base 3 of the left hand side, I'll just write that down, log base 3 of 3 to the x equals log base 3 of 10. Now log base 3 and 3 to the power cancel, so we've just got x, log base 3 of 10. And then what you do is you use the change of base rule. You're going to get back to here. I might change it to base 10 this time, but it could have been base e. So the change of base rule is log, this time I'm going to do base 10 of 10 over log base 10 of 3, which is exactly the same as that, which you just saw me put in the calculator. We get the same answer. So those methods are both really just as good as each other. I tend to do it this way, but this is fine as well. Okay, example 2 is similar to some ones we were doing earlier in the chapter. A population is decreasing according to the formula n equals 500 plus 20 e to the negative 0.03t. Earlier in the chapter I mentioned if this is negative it's decreasing. If it's positive it's increasing, because negative you've got that kind of shape. So find the initial population. Well, that's just when t equals 0. So the initial population would be 500 plus 20 times e to the negative 0.03 times 0, so just 0. E to the 0 is 1, so that's 500 plus 20 times 1. So initially 520, whatever the population is, I don't know if it's people, animals, birds, whatever. But initially there are 520. One of the interesting things about this one that I'll just mention as an aside is if you put this in your calculator with a really, really, really huge number for t, this thing here gets really close to 0. So there's actually what we call a limit on this population. That this whole thing would be 0, so 20 times 0. So the population's not going to decrease below 500. 500 is going to be the minimum. It's what we call the limit of that decrease. It limits at 500. Never goes below 500 because this thing can't be negative anyway. Okay, how long will it take until the population reaches 505? So if we put 505 into our equation instead of n to solve that, so the equation becomes 505 equals 500 plus 20e to the negative 0.03t. We need to subtract 500 off each side, so minus 500 minus 500. So this side is 5 equals 20e to the negative 0.03t. I'm going to divide each side by 20. So 5 on 20 is the same as a quarter. I'm just going to turn it around. I'm going to write this bit on the left and this bit on the right. So e to the negative 0.003t equals 5 on 20, or 1/4. Now I need to do the opposite of e to solve that. So I do need to take the log base e of each side is what I'm going to do. So log of that, log of that. So the left-hand side becomes negative 0.003t, and the right-hand side is log 1/4. You might remember that log law there. That's the same as negative log 4. You don't need to do that, but you can. Divide each side by negative, I'll just write that side again. Let's divide each side by negative 0.003. See, I could have just done log 1/4 divided by negative 0.003 as well. I would have got the same answer. So I'm just going to put that in my calculator. I won't bother putting the negatives in because obviously they cancel each other out. So I've got log 4, close the bracket, divided by 0.003. 462. I might just do the nearest whole number there. Now, 462 what? Well, we were told up here t is time in days, so it's 462 days, and it is really important to put those units on there.